In today's video, we will teach you what springback is and how to calculate it using the Ercolina SB48+. Rotary draw bending uses a former to pull the material around an axis. Every material has elasticity, so it naturally resists this movement and tries to return to its original shape. This means, once your desired bend is complete and the former returns, the material will be underbent. In other words, the final resting angle of the part will be slightly less than the angle you actually bent it to. Now that we've returned the former, we can see the angle is slightly underbent and not at the 90 degrees we want. This happens because the outer part of the tube is stretching while the inner part is compressing, making the material spring back toward its original shape. Other factors that affect overbending include subtle mechanical differences in the machine, such as wear or calibration, as well as the tooling fit-up, which involves any delay or clearance for the material to properly seat into the former before the bend begins. The biggest variable is the material itself. Mild steel, stainless, aluminum, and copper all have different springback rates. That's why the next step, testing your material, is so important. To calculate the springback, you'll first program your target angle into the machine. For this crucial initial test bend, make sure the springback compensation entry is left at 0. For our example today, we are going to be making a 90-degree bend. It is important to note that for this specific test, we are working with 1.25" mild steel pipe. Now that we've completed the bend to 90 degrees, let's remove the piece and take it to a level surface so we can measure the actual resulting angle. The angle finder reads 102.7. Subtracting that from 180 gives us 77.3 degrees. That's our final bend angle. Subtract that from our target 90 degrees, and we get a 12.7 degree springback. Let's go over to the machine and program our springback. Let's try it at 13 degrees. On this final bend, we should find our actual angle is much closer to our desired 90 degrees. Once we take the piece out and measure it, we can see if any final correction is needed. A result of 90.4 degrees is excellent and well within our threshold.